Happy Thursday. I hope everybody is doing well. I am going to clear up a couple questions that I had emailed to me about the practice problems from yesterday. So we are going to look at question 6, question 10, and question 11. Okay. So starting with question 6, we have to factor the polynomial if possible, and if it cannot, we're going to call it prime. So if we notice here, 4x squared plus 9x minus 16, we're tempted to go right off the bat and say, hey, this is a perfect square. Well, if we look at that, yes, 4x squared is perfect. It has a factor of 2x. Okay, so it does have a factor of 2x. However, it is easy to skip this negative in front of the 16. Because of this negative right here, we are trying to figure out if negative 16 is perfect. And if we think back to perfect squares, if we did 4 times 4, well, that's got to be positive 16. My only other option is negative 4 times negative 4, which is still positive 16. So because of that negative, it is not a perfect square trinomial. So we have to use alternative methods. Okay, so unfortunately, since the coefficient on our x squared is a 4 and not a 1, we have to try the grouping method. Okay, so if we look, we have to multiply the 16 and the 4, so we get negative 64. So we need two numbers that multiply to give us negative 64 and add to give us 9. So if I go through my factors here, 64 and 1, that's the most basic. That doesn't give me 9. Okay, so that doesn't work. So I go to my next factors, 32 and 2. Once again, that doesn't give me 9. How about 16 and 4? Well, that once again does not give me 9. And my only other factor is 8 and 8, which definitely doesn't give me 9. So if we notice, all of the factors of 64 never add up to give us 9. No matter how you look at it, if you put negatives in there, it is not going to add up to give you 9. So that means, since there are no greatest common factors and we can't factor it by grouping, that this is a prime polynomial. Okay, so chances are if you were having trouble, it's because of that negative, or you were having a hard time trying to figure out it was prime. But that one was a little bit tricky, and I hope that cleared things up. Okay, we're going to move on to number 10. I didn't have any specific questions about number 10, but it is a little bit tricky, so I wanted to go over it for you. So if we're looking at number 10 says we need to solve each equation and then confirm using a graphing calculator. If you want to use the Desmos graphing calculator to help you with these, you absolutely can. You are looking for the zeros or where it crosses the x-axis. Okay. So on number 10, we have z plus 5, and that quantity is squared, equals 47. Now, when solving these equations, you don't necessarily have to use factoring, okay? Factoring is helpful in some cases, but in this case, we don't need to factor. It's already factored for us, okay? So what we need to do on number 10 is, well, we need to solve this z plus 5, but it's squared. So to undo the squaring, remember, we have to take the square root. But if I take the square root on the left, I also have to take the square root on the right, okay? Excuse me. And when I take the square root, I am left with z plus 5. And when I take the square root on the right, I am left with plus or minus the square root of 47. 47 is not a perfect square, so we just leave the radical sign. Okay? That plus or minus tells me, hey, it could be positive or it could be negative. Okay? My last step, I have to get z by itself, so I subtract 5, and I subtract 5. So my ending result, notice these 5's cancel, so I get z equals negative 5 is going to stay the same, plus or minus the square root of 47. And you can just leave your answer just like that. You don't have to do anything out of the ordinary to get your final answer. If you just want to leave that plus and minus, that's it. That's all you have to do. If you want to actually find an approximation of this answer, you can, but I'm just going to leave it as it is. Okay, number 11 is one of those word problems with that negative 16t squared plus h sub 0. Okay, so while painting his bedroom, Nick drops his paintbrush off the ladder from a height of 6 feet. So this is his starting height. So we need to use the formula h equals negative 16t squared plus h sub 0 to approximate the number of seconds it takes the paintbrush to hit the floor, which means his final height is going to equal 0. Okay? So h is the final height. This is the final height. And the final height for this paintbrush is going to be 0 feet. Right? It's going to be on the ground. It's not going to be off the ground at all. And we are trying to find how much time it's going to take, so t is going to stay the same. And then h sub 0, that is the initial height. Okay? And the initial height of this paintbrush was 6 feet off the ground. So we're going to put the 6 right there. Okay? So this was the initial height, or the starting height. And now we can solve it. Okay? On this one, we can subtract 6 here if we wanted to. So we would get negative 16t squared equals negative 6. We can then divide by the negative 16. So we would get 6 over 16, which will reduce to 3/8. And we are left with t squared on the right. Once again, to finalize this, we are going to take the square root. And keep in mind, this is going to be plus or minus the square root of 3/8, and that's going to equal t. But if we're talking about time, okay, we are not going to use a negative time. So if I take the positive square root of 3/8, and I need to approximate that number, so the time is going to be about 0.6 seconds. Okay, so that is the approximate time it took for the paintbrush to hit the floor. Okay, I hope this was helpful. At the bottom, 12 through 15, if you're struggling with those, remember you're just trying to figure out if the first term is a square, if the last term is a square, and the middle term has to be the product of those two factors and 2. Okay, so you can look back at the previous video to help with those. Okay, hope this was helpful. Email me if you have any questions, and I will get back to you as soon as possible. Thanks.